we're going to go over 5.7, which is going to deal with integrating to natural log. So the idea is this first question, this first indefinite integral, has a 2 on top, and what I'm going to do is I'm going to push that 2 out front and save it for later, that 2 over 1. And maybe another way I could rewrite this is I could say I have dx over x. Yes, I do have 1 over x dx, or sometimes I like to write it like this because this literally says, what do I have? I have the derivative of x over x. I've got the derivative of something over itself, and that should sound familiar. Derivative of something over itself comes from ln. So this must be 2 ln of x, but when we integrate to ln, there's one extra step. We need to make sure that that inside algebra is nested inside of absolute values. Right, so that would be our first integral to ln of, let's see here, absolute value x, and don't forget your plus c. All right, and they give you the reminder to use absolute value when appropriate. Now, why did they say use absolute value when appropriate? Well, because maybe somehow through some math, I don't know, we got something that was like ln of x squared. Well, if that's what we got, then there actually is no need for absolute values because when you square something, it becomes positive in itself. So just be aware that there might be some times where the absolute value can be ignored because something going on the inside is already going to produce positives for us. But let's just keep going. All right, up next, on the next example, I'm still going to pop out that 2 and ignore it for now. I've got a dx over x minus 8. Now the thing here is that x minus 8 is a little bit more complex algebra, so maybe we could do some u substitution and say that u is x minus 8. Well, if that's true, then du is actually just dx. Interesting. So what does that get me? Well, there's still the 2 out front, and now on the bottom I just have u, and on top I just have du. So once again, I've got 2 times the derivative over itself. It just is a u this time. So I am going to have 2 ln absolute value u plus c. And of course, the last step is to say, well, this problem wasn't originally u. It was originally x minus 8. So put that in absolute values. And there is your answer. 2 ln absolute value x minus 8. And don't forget the plus. Oh, goodness. Don't forget the plus c. All right, there we go. Up next, now things get a little bit more interesting. It's still going to be kind of a u sub-ish problem. Zoom in on this a little bit. All right. So up next for our u sub-ish problem, I'm going to jump right into defining what u is. I'm going to say that u is 2 minus 8x, and that means that du is simply negative 8 dx. Now, the good news is the 2 minus 8x has completely dealt with like all the algebra, so to speak. The bad news, though, is I don't have a negative 8 dx. I just have technically a 1 dx. But that's okay because since these are multiplying, I can just divide negative 8, and now I have my 1 dx. So my new integral is negative 1/8. I always like to push out that constant multiple, or divisor in this case. So negative 1/8, and now I've got du over u. So again, we're in an ln situation. So maybe before we move on, it's time to talk about how do you know you're in an ln situation? Well, maybe if you notice a fraction, you look at the denominator and ask yourself, if I derive this, will all of the powers of x I need of the derivative be in my numerator somewhere? And the answer actually is yes for this case, and we're kind of seeing that even though there's an 8x, in other words, 8x is going to derive to a constant, and my numerator only has constants. So my numerator has the form of derivative I need. I've got algebra on the bottom and constants on top. Well, guess what? If I derive this algebra on the bottom, I'm left with only constants, so I can do u sub. So finishing this up a little bit more quickly, there's the negative 1/8. I'm going to have an ln absolute value of something, and why not translate it back into x as I go? All right, so there might come a point where I stop typing these in for sake of time because we've got a lot of examples to run through, but I'm still feeling motivated at the moment. After all, you're going to have to do this yourself. Okay, up next, again, here's more of the idea of what I was talking about if it sounded a little vague. I've got a denominator who's going to derive to a negative 5x to the fourth. Or in other words, all that algebra on the bottom is only going to result in something with an x to the fourth. And guess what? That's what my numerator has. So I can set u to be the entire denominator. And that means du is going to be negative 5x to the fourth dx. Again, the only issue is I don't have a negative 5x to the fourth. I just have a 1x to the fourth. And again, we can exploit some division and get what we need. So there's a negative 1/5. If you don't mind, for sake of time, I'm going to already understand that this is an ln integral. After all, that's the section we're in. It's going to turn back into x and my plus c. All right. Up next, this one I'm going to do even faster because although the algebra is more complex, look at your denominator. And what do you get when you derive your denominator? You actually get your numerator exactly. There's no extra multiplying or dividing number. I get literally my exact denominator derived in my numerator. So this is a great ln situation. It's literally just ln absolute value of my denominator plus c. All right, when I derive this again, I'm going to get, this derived, which is 3x squared plus 8, there it is, over the original inside, x cubed plus 8x, there it is. All right, now this is where things get a little bit interesting because we're in the ln section, but I no longer am kind of following the same conditions that led me to think I was in an ln situation before. And what I mean by that is this time my denominator doesn't derive to my numerator. My denominator derives to actually just 2, and my numerator is definitely more complex than just a constant number 2. To get around this, though, what I'm going to realize is that I'm dividing by what we would sometimes call a monomial, a single-term expression. So what I could do before I even consider ln is I could clean up some algebra, and I could say, well, let's look at the inside here. Let's look at x squared minus 2 over 2x. Why don't I write it like this, right? Why don't I split that single denominator over every single term? It's like we had a common denominator and combined, but why don't we go in the opposite order and see what that does for us? This lived in an integral, so maybe we're ready to bring it back. I would now simply have x over 2 minus 1 over x, and that would then be having a dx distributed to it now that it's two distinct fractions. And this is already ready to go to solve the problem. Be careful because x over 2 isn't ln. This is actually just a basic reverse power rule. Where does an x come from? It comes from x squared. And a 2 is going to drop down and leave me with 1/2. So I need to offset it with its reciprocal 1/2 with the 1/2 already there, so I get 1/4. Again, if I drop the 2 down, I get my 1/2 and I get my power of x. Now I have negative, so there's the negative, 1 over x. So in other words, I have negative derivative of the bottom on top, which is ln, absolute value of that bottom structure, plus c. Right? So rewriting before integrating is a vital skill. There are times where, yes, ln might be involved, but it's not the first thing you're going to do. The first thing you're going to do is see if you can make the problem a little bit easier visually, or algebraically to understand what needs to be u-subbed or ln'd or what can just be simplified and worked out by a reverse power rule. Okay, this one looks like it might actually be the same idea. It kind of looks like maybe we can do some factoring with this almost. I think I can do some factoring. So in this case, I think I've got a common 2. That would be x squared plus x minus 4. But there are no factors of 4 that subtract to 1. There's 2 and 2, and there's 1 and 4, so that's a little bit interesting. What can I do now? Once again, also, it's not like the denominator derives to the numerator. I think what we're going to do here, is we're going to pull out synthetic division. All right, so this time, it kind of follows like the last example. Hey, we could probably do some dividing. That was easy when there was a monomial, but now there's a binomial. But thankfully, that binomial is linear, and we can easily find what makes it equal 0. So this is a great time to use synthetic division. So synthetic division says write down the coefficients of your numerator, and make sure you drop the first one. And then write what makes that denominator equal 0, or the root of the denominator. let's do synthetic division. Now the thing is, I know this doesn't factor well, or in other words, I know that that 4, or that x minus 4 isn't going to divide this cleanly, but that's actually going to be okay. So when I run through the synthetic division, I get 8, I combine and get 10, I multiply and get 40, and I combine and get 32, and there's my remainder. Like I said, it doesn't work out perfectly, but it's still going to allow me to do the integral, because I can now say that this integral is really 2x plus 10. Now what's going on there? Well, again, if this refers to a single number, an x and an x squared, then after my remainder, I've got a single number, an x, and so on, however many terms you have. So this is the quotient of the synthetic division, and of course there's a remainder. And how do we write remainders? Well, we write the value of the remainder divided by my divisor. All right, and now we're ready to integrate. 2x comes from x squared, 10 comes from 10x, and this looks reminiscent to some of the earlier questions, like maybe question 2. We're going to have that 32 move out front, right? Move the 32 out front of just this section of the integral, and now I've got 1 over this thing. And again, 1 is the derivative of this thing, so we are now in an ln situation. And don't forget the plus c. Right, and there we go. I think what I'm going to do now is, let's see here. This one follows the same idea, so I think I'm going to skip over this one, but do your synthetic division. This one's a little bit more interesting because you're going to have to rely on polynomial long division because that does not factor nicely. So maybe we'll take a look at this one before we end this video. All right, so we're going to have to do actual polynomial long division. Or in other words, hey, there was a reason you learned that earlier, even though we like to forget it. We have an x cubed, we have a negative 4x squared, we have a negative 7x, and we have a plus 32. Remember that if any power was skipped, that you're going to need to fill that in with a 0. We've got x squared minus 8. Okay, so what's going to happen here is we say, how can I get x squared to be x cubed? Well, I just need to multiply an x. But if I'm multiplying an x to this, I need to follow the distributive property. So I do get my x cubed, I get my match that I was looking for, but I also get an extra negative 8x, which I'm going to line up with the other x term. And division then says, well, subtract, or change the sign of everything you just found. Those cancel completely, we'll bring down our next term, we'll combine those terms, and we'll bring down the next term because it kind of looked like we were going to use terms with a space in the middle. So now the question is, how do I make x squared negative 4x squared? Well, I just need to multiply a negative 4. So I get my match that I was looking for, but through the distribution I also get an extra positive 32. And once again, I need to change the signs or do the subtraction. So interesting, it looks like my integral is really x minus 4 plus my remainder, which is x over the x squared minus 8. The interesting thing about that is, of course, well, now that is an ln situation because x squared derives to 2x, or some form of a single x. So we're good to go. That's going to integrate to x squared over 2. This is going to integrate to negative 4x. Sometimes you might set your problem up like this. You know you're going to have an ln of absolute value x squared minus 8. So you know that when you derive this, a 2x is going to pop out, but I only see a single x, so there must be a 1/2. Or in other words, if you write out the entire u sub process, you'll see a 1/2 du show up. But you can, depending on your comfort level, start to maybe just understand what form it's going to take and then figure out what number pops out in reciprocals on the outside afterwards. All right, so we'll type this in, make sure it's right, and that'll be the end of this video. X squared over 2 minus 4x, and now we're flying blind, 1/2 ln of absolute value x of x squared minus 8. Don't forget the plus c. How'd we do? We had an extra set of parentheses. So maybe let's eliminate those if possible. Cool. All right, let's check our questions and see if I made any pesky errors. No. We skipped that one, and no. Awesome. All right, so we'll continue on the next video with question 10.